So this was a pop quiz 10, which was related to topic bonding rate and the moles. So the first question. The first question, a student adds access large pieces of a magnesium carbonate to a hydrochloric acid, and he measures the volume of a carbon dioxide gas given off. Add the missing state symbols to the chemical equation. So carbonates, as most of the carbonates are insoluble. So what is the state of carbonate? That will, because it is insoluble, so it will be solid. Acids, alkalis, and soluble salts, they are all aqueous. So we write AQ if it's an acid or an alkali. Magnesium chloride is a soluble salt, that's why it's written aqueous. Water stayed at room temperature, it is liquid. And we have carbon dioxide stayed at room temperature is a gas. So first part, you have to add the state symbols. The second part, complete a dot and cross diagram for magnesium chloride. So when we write the electronic config, because like magnesium chloride formula, it's MgCl2, like 1 magnesium and 2 chloride. So magnesium belongs to group 2 and it is having total 12 electrons. The first shell it will have 2, second shell it will have 8, the third shell it will have 2. This is magnesium atom. And chlorine, as it is, proton number is 17 for chlorine atom. So like there will be 17 electron, 2, 8, and 7. So what will happen? Magnesium will lose electron, like because the metal tend to lose all their valence electron. So one electron transferred to one of the chlorine atom and the second electron to the second one. You don't have to draw these arrows or show this transfer. You need the final diagram. So as these electrons are being transferred, so there will be no electron in the last or the valence shell, and each chlorine will get one electron. So because each chlorine gain one electron, the charge on each chloride ion, that is -1, and magnesium loses 2 electrons, so it will be +2. So this is the dot and the cross diagram for magnesium chloride. In which then it's up to you. You can draw the third shell as empty. It shows that electron is being transferred. Or if you draw only 2 shells which are occupied one, this is also correct. Then we have to draw dot and cross diagram for a molecular arrangement of a carbon dioxide. To show dot and cross diagram, you have to check the element, like carbon is there, belongs to group 4. So group 4 element, it will share 4 electron. And there will be no unshared electron. Oxygen belongs to group 6. Group 6, they will share 2 and unshared will be 4. So we start sharing from the last one, like from the ends. So if oxygen share 2 electron, carbon can share 2 electron from that side. Total carbon should share 4, but from that side it should be 2. Same thing, if oxygen share 2 electron, carbon will share 2 electron. An unshared electron on carbon, there is no unshared electron. And each oxygen, there should be 4 unshared electrons. So 1, 2, 3, 4. And same way, 1, 2, 3, 4. So this is the structure of carbon dioxide, in which you draw the shared electron, like a pair of electron between the carbon and oxygen. 2 pairs are there. And unshared electron, 4 unshared electron on each oxygen. Then the graph shows how the volume of a carbon dioxide changes with time. how the graph shows that the rate of the reaction decrease as the time increase. Look, remember one thing, the slope of this graph represent the rate of the reaction. So you can just mention the slope or the gradient or the slope decrease, which shows rate decreases, because rate of a chemical reaction equals to the slope of volume time graph or a mass time graph, like volume of a product time or a mass of a product time graph. Explain in terms of particle why the rate of this reaction decrease as the time increase. Why the rate of a reaction is decreasing as the time increase? Because in the beginning we'll have more reactant particles. The concentration or number of particles in the beginning are more as compared to as the reaction progress, the number of the particle decrease. So less collision, that's why slower rate. So number of the particles or reactant particles, you can say, decreases, which reduce the number of collision and lowers the rate. The student repeat the experiment using a powdered magnesium carbonate instead of large pieces. All other conditions stays the same. On the grid, draw a line expected when a powdered magnesium carbonate is used instead of large pieces. So if we use the same amount, but now the powdered. So if we use the powdered form, what will happen? It will have large surface area, small particle size will have a large surface area, but the final product does not change. So it will be steeper, level off quickly, and then same line it will end. Why it will end at the same line, like horizontal? Because it shows that this reaction is faster, but the amount of a product is not changed as we use the same amount of the reactants. Question part E is related to the moles. The first part, determine the volume of a carbon dioxide gas given off when excess of a magnesium carbonate is added to 25 cm cube of 0.4 mole per dm cube hydrochloric acid at room temperature and pressure. Calculate the number of moles. So we have the volume and we have the concentration. So how to get the moles? So moles equal concentration into volume. The concentration is 0.4, but the volume is in centimeter cube. So we have to convert into decimeter cube divided by 1000. So it will be 25 divided by 1000 to convert into decimeter cube. This will give us the total moles of hydrochloric acid which are used for this reaction, that is 0.01. So we can say 0.01. Then the number of moles of carbon dioxide. So what is the ratio? Because like first part we solve by formula. So it is obvious the second part is by ratio. So we will take a ratio between hydrochloric acid and carbon dioxide. Hydrochloric acid and carbon dioxide, the ratio is 2:1. So if we have hydrochloric acid 0.01, then carbon dioxide will be X. We cross multiply. So X 0.01 times 1. So it will be 0.01 and 2x divided by 2. So this will be 0.005. So these are the moles of carbon dioxide. Then calculate the volume of a gas given off in centimeter cube. So we have the formula that moles equal volume of the gas divided by in decimeter cube. So moles equal volume of the gas in decimeter cube divided by 24. 24 is divided, so other side will be multiplied. So how many moles are there? 0.005. And volume in decimeter cube divided by 24. 24 is divided, other side will be multiplied. So we get 24 times 0.05, which is equals to 0.12. But that is in decimeter cube. The question is, we have to find in cm cube. So to convert the decimeter cube into centimeter cube, we multiply by 1000. So it will make 120 centimeter cube. So that is the volume of the carbon dioxide in cm cube, which we collect in this reaction. Is it a clear discussion? So this was a pop quiz which was related to bonding rate and modes.